placed to its proper position, the remainder of the rectangular duct will be fit using the fit command. Similar to connecting the supply, we will now connect the return duct. C.A.T.S has designed a very useful and user-friendly command of being able to move objects in the X, Y, or Z direction between components to connect without having to calculate elevations or center lines. We can now review our mechanical room layout in three-dimensional view. Perhaps the most important part of any project is the ability to install your material in the space that is designated after the coordination has been completed in the design. If the project is not coordinated prior to manufacturing of components, the result is rework of the improperly located materials. Remember, we only get paid once to install it. We begin by turning the fire sprinkler layers on. We will switch our drawing to a single screen format. In the C.A.T.S Commander, under Ventilation, we will find under Tools, Crash Detection. The Crash Detection window appears. Select Check. We will select the entire drawing to perform our collision check. The crash detection is processing each coordination point for each collision. The colliding coordinates are listed in the C.A.T.S collision detection window. By double-clicking on the collision point, you will be directed to that point on the drawing. It will zoom you to the point automatically. Here you can see that the fire sprinkler branch line and the supply duct are in conflict. We will delete one duct section. The correction will be made by moving the supply duct forward 12 inches and down 4 inches. We reconnect the section through the offset command. On the adjacent return line, we will revise the drop of the offset and fit to the fire damper another offset. We will continue to correct our list of collisions until the process is completed. Changes to the initial design and placement of your devices can be changed easily within the CAD software. The designer will discover a system of tools to facilitate redesign or relocation of components and can complete the task easily. We change our view to a top view. We are now rechecking the CAT's clash detection for any missed items. The same procedure will be followed. There remain 2 unresolved collisions. Again, by double-clicking the coordination points, the collision is zoomed to. Upon examination, we find the conflict between the flex duct and the sprinkler pipe, and the air diffuser and the sprinkler pipe. Obviously, the flex could be redirected. Inasmuch as the line also conflicts with the diffuser, we will relocate the diffuser to fix both collisions. We will now relocate and reconnect the diffuser. We will check again for any collisions. However, this step is not really necessary. As you can see, no further collisions exist. Within the C.A.T.S software products, the user is capable of making pressure drop calculation within the framework of his project drawing, without using a third-party software calculation program. The true layout of the systems, ductwork, piping, etc. is in front of you, so what better place to make your pressure loss calculations? In this demonstration, we will present to you the C.A.T.S Intelligent Software Solution. We will turn off the sprinkler layer for our calculation. We will also turn off the air handling unit layer as it does not affect this calculation. In the C.A.T.S Commander, under Calculations and Lists, we will find Create 3D Components. This step is necessary after altering the design after the changes you have made prior to performing the calculation. Highlight the entire drawing. Select Enter. Under the C.A.T.S Commander, under Calculation and Lists, you will select Perform Pressure Loss Calculation. A window appears, Pressure Loss Calculation. Choose Exhaust Air, select the temperature to 80 degrees Fahrenheit, and the drop-down menu, select Sheet Metal 4-foot joints. Select OK. We now select the starting point of the return duct. The pressure loss calculation window appears. The total CFM and pressure drop is indicated for the return system. All components are listed with their respective pressure drop by fitting. Select the Report tab. In the report, you can select parameters of your report. The pressure drop of the return duct system is 83 Pascal, or 0.33 inches static pressure. The same procedure will apply to the supply duct. The pressure loss calculation window appears. We select Supply Air. We will set the temperature at 74 degrees. The calculation takes into account the viscosity, pressure on the building, and density of the air. Here again we have our total CFM and pressure drop of the entire supply duct system. All information can now be transferred to an Excel report. Each fitting in the supply duct system is listed with its associated pressure drop. Each diffuser is listed with respective pressure drop. The required damper position for the branch line feeding the diffuser or position of the damper located on the diffuser has also been calculated. This is a unique function of C.A.T.S software and of tremendous value prior to system test and balancing. The pressure drop of the supply air system is 130 Pascal, or 0.5 inches static pressure. The total external static pressure of the system is 230 Pascal, or 0.83 inches static pressure. By choosing a section of our supply air pressure drop calculation, the selected section will be zoomed in. Any changes or modifications to this section may be made at this time. For example, should a branch from the supply air main duct have an excessive pressure drop, this type of connection could be modified. C.A.T.S software offers the ability to print material list requirements for the production facility. This can be downloaded as a printable document or in a file interface that could be put into devices similar to a plasma table for sheet metal cutting or other automated production equipment. We will now restore the drawing's original characteristics. The position numbers layer from the pressure drop calculation is turned off. In the C.A.T.S Commander, we will dimension the duct sizes by clicking on the duct flanges or the sides of the round pipe to show each dimension. In the next window, the attributes are indicated for duct elevations. The user can select top of duct, center line, or bottom of duct. Select OK. The user can click on the duct section and drag the elevation box for the duct onto a position that is readable on the drawing to be printed. In the C.A.T.S Commander, item tags may be selected to differentiate between various components within the system, such as flex duct, diffusers, and all other components. Here we select a diffuser, indicating the type of diffuser and the CFM. In the C.A.T.S Commander, you can assign item numbers of duct or fittings on the drawing. Here we select the return air system. "21 pieces are found." We will now assign the type of error, R for return, and select the start object. We can then assign the number sequence we choose to use. We will repeat this on the supply air system. The software finds 60 pieces. We will select S for supply, our start point, and assign. Now the item numbers can be relocated to a position that they are better readable on the drawing. We now return to the CAT commander under Calculation and List, and we will now find the icon, Bill of Materials. Highlight the entire drawing. A window appears, Format File. You can choose the type of material list you would like generated. For example, Excel component with description. A sheet with item numbers is generated. An Excel spreadsheet for duct may also be generated in the order of their item numbers. Information such as gauges for duct and fittings, lengths, requirements for joint material, square footage of material, etc. is produced for the fabrication facility.